Get ready to climb the ladder to success, because today on Made in Virginia, we're reaching new heights with a Bristol manufacturer that makes over 100,000 feet of ladder rail each day. The process in which Strongwell, the unquestionable world leader, produces ladder rails, construction beams, utility poles, storm and armor-grade panels, and much, much more is called Pultrusion, and it's all made in Virginia. Made in Virginia is brought to you by At Union Bank and Trust, we salute the dreamers, the thinkers, the doers, the believers, the builders, and the makers. Thanks to your vision, hard work, and innovation, you make Virginia shine. Union Bank and Trust, a partner of Virginia business and a proud supporter of Made in Virginia and Virginia Public Broadcasting. Bristol, Virginia, home to the birthplace of country music, is an extraordinary and lively small town. You see, the Virginia and Tennessee state line runs right down the middle of the aptly named State Street, which separates Bristol into two towns. Right up the road in Tennessee is the Bristol Motor Speedway, and right up the road in the Virginia side is the Strongwell Corporation, with over 647,000 square feet of manufacturing space and over 10,000 square feet of laboratory space. Strongwell is the undisputed world-leading manufacturer of pultruded products and machinery.
Well, I came here and I really had a lot of experience in compression molding and hand layup, filament winding, and zero experience in pultrusion. And I knew a lot about these other processes, and I knew the jobs they had, and they were bad jobs, low price, couldn't make any money. And we were already probably at that time the largest pultruder at about $900,000 a year. And so I had to meet the payroll, so I started selling some of this other equipment and concentrating more on pultrusions, and we continue to grow, and still today we're the world's largest pultruder.
Absolutely. I think we're all proud to be a part of that, and we tout that, and we tout that we're the world's largest and most efficient pultruder out there. But yeah, and the reason that we do that is we found that either from a lead time or a quality standpoint, we could not source a lot of the things we do as well as we can do it ourselves. From making our own tooling, it's faster. It's not always cheaper to do it yourselves, but it can be faster, and the quality can be exactly what you want. And as far as building machines, that goes hand in hand with developing new products. Most pultrusion machines, up until a couple of years ago, they were either big and powerful, which meant they were very slow, or they were fast but not very powerful. In a lot of the product development that we're doing here in Bristol, we're experimenting with new glasses, new resins, whether it be, and some of it's not even glass, carbon fiber, epoxy resins, polyurethanes, where you need to pull both fast and with a lot of pull force. And the existing pultrusion machines out there just won't do that. So we build our own so that they will. And two of the newest machines that we built will pull over 120 inches per minute with over 150,000 pound pull force each. So that is a monster machine pull force and a small machine speed. And some of the products that we have can't be made on anything else, which means no one else in the world can make them.
Pultruded products, you may ask yourself. What are pultruded products? The simple answer is products which are made utilizing the process of pultrusion. And although you may not yet know what pultrusion is and how it is accomplished, the fact of the matter is, most likely you have come in contact or used in some way a pultruded product today, and that there is a good chance that it was manufactured in Virginia by the Strongwell Corporation, or came from one of their pultrusion machines located throughout the world. Highway bridges, power poles, coastal construction, oil rigs, building materials, tool handles, decking, fencing. The list goes on with a vast array of custom pultrusion applications. So now that you have a good idea of the boundless scope of pultruded products, it's time to learn just what pultrusion is. Pultrusion is the process in which continuous lengths of fiber-reinforced polymer, or FRP, that maintain constant cross-section dimensions are produced. The raw materials for FRP are a liquid resin mixture and continuous strands of glass fiber filaments known as rovings, cross-stranded filaments known as continuous filament mat or mat, and a final layer of protective fabric known as the surfacing veil.
Well, most people think about fiberglass and they think about, oh, well, that's the pink stuff in my attic. That's not at all what it is. Most people would walk into a Lowe's or a Home Depot or one of those kinds of stores and they could go down the ladder aisle and see a fiberglass ladder. Those came about because fiberglass is electrically non-conductive. In other words, you're not going to get shocked if you're on a fiberglass ladder as you might if you're on an aluminum ladder or similar. Well, that's just one of the hundreds, literally hundreds of applications, especially when you're going to have issues of rot or weight or things of that nature. For example, we do a lot of applications along coastlines because steel rusts, wood rots. Well, fiberglass doesn't do any of that. We do a lot of things in offshore oil and gas platforms because of weight issues and also because it doesn't rust or rot. Steel, you can put it out on the ocean and you know what's going to happen. With our material, that's not going to happen. It's going to last. The durability factor is dramatically different with fiber reinforced polymer, FRP, versus what you're going to get with traditional materials.
Not a lot of people understand pultrusion. However, it has similarities to extrusion in that we are making a constant cross-sectional area. However, there are differences between pultrusion and extrusion, one being that we are continuously pulling through a die. So we can pull longitudinal reinforcement and make a structural composite. So you can pull a roving through a die, but you cannot push a roving through the die.
You've heard of extrusion, and that's primarily with thermoplastics, and we deal with thermoset plastics. And in thermoplastics, you melt pellets, and you have a screw machine, and you film and what have you, and you force them through a die that's about that long, and the material is hot, and as it cools down, it gets hard. Make a bad part, you can grind it up, regrind with new material and recycle it. Good example is Coke bottles, recycled Coke bottles. That's called extrusion primarily. Pultrusion, we have these reinforcements that you saw. They're sort of like a wet noodle. They're very high strength, but you know, you can pull them, but you can't push them. It's like pushing a wet rope. So we grab hold of the finished product if it comes out of the die and pull on it. And it's a exothermic reaction. Chemical reaction takes place in the die. Our dies are typically 40 to 50 inches long. They're heated. Room temperature material goes into the die, wetting out the reinforcements. A chemical reaction takes place in the die. Out comes a hard part, and we're grabbing hold of the hard part and pulling it. Pultrusion.
The process begins with the pulling of the rovings and mats, using either a caterpillar or a reciprocating style puller through a series of guide plates and preforming tools into a resin mixture. The proprietary resin mixtures are formulated to specifications determined by the required attributes and environments in which they will serve. The now resin-impregnated rovings and mats are layered with a surfacing veil of fabric for smoothness and UV protection. This array of fibers are then wetted out in the resin bath to assure complete saturation. With each step in the process, the raw material is getting closer to the shape of the die.
The science is, it's the pultrusion piece of composites. It's relatively simple. You are pulling resin and glass and filler through a heated die where you're having both a chemical and thermal reaction to have a solid shape. Seems pretty simple. And that's why a lot of people jump into the business thinking they can do it. The art is putting the materials exactly where you want the materials and not having the materials move around on you. So as you walk through our plant and you see a lot of the preforming equipment that we have before it gets to the die, that's where the art and the science is that glass has to be exactly where you designed it to be, and it has to cure at exactly the point in the die that you want it to cure to yield the properties that you want to yield. If you take one of our parts, and we've done this, we've got market studies where we've done it, you take our part and you take, say, a part made in China, and they look exactly the same, but if you mechanically test them, there is a big difference. And the reason is a lot of the foreign-made product is the material's not where the designer designed it to be. It moves around, and that's where the art comes in. And the operators have to be well versed in understanding if the material is moving or is wadding up and going to create a breakdown. There is a lot of art from the operator in maintaining that material where it needs to be.
The wetted out fibers being continuously pulled at a specific rate of speed go through a preformer and then through the former and curing die, which determines the final shape. From there, the finished product, a fiber-reinforced polymer, is pulled down the line where it is cross-cut. For Strongwell, success is measured in many ways. Consider running over 65 Pultrusion machines, each with the capability of handling up to 40 lines while offering custom production right down to multi-cavity machines and individual parts. Pultrusion is not a fast manufacturing process. Product lines are measured in inches per minute, certainly not fast, but exacting and continuous. Another element in which this Bristol Virginia world leader has made its mark is in the engineering and fabrication of its highly sought-after pultruded fiber reinforced polymers. Strongwell maintains nearly every engineering discipline on staff with multiple registered structural engineers. They not only design it, they manufacture it and put it together to meet exacting specifications. A big part of Strongwell's capabilities is its research and development and testing lab. Because when you are manufacturing products that touch nearly every segment of the construction industry, as does Strongwell, with a nearly endless range of applications, you must ensure the structural integrity of the products and that they will perform as specified in various and often harsh environments. Strongwell's products are vigorously tested to ASTM standards, and in fact, because of Strongwell's innovation, always raising the bar, new standards are being developed. Deflection tests are designed to stress a part to measure various aspects of its mechanical performance. What is called coupon testing takes into account the properties of small sections of a product to measure the mechanical properties of any given part of the final product. Because FRP is well suited for harsh environments, products are tested that simulate extreme conditions. Pultruded fiber reinforced polymers are not generally flammable, and even when ignited with another fuel source, FRP is self-extinguishing when the fuel source is removed. Now you might think Pultrusion technology and the machines are developed, manufactured, and imported overseas into Virginia, but you would be wrong. This operation is, from its conception to completion, 100% made in Virginia. If you are an overseas company and you want to get into the Pultrusion business, Strongwell in Bristol, Virginia is where manufacturers the world over come to have their machines built. Strongwell has placed over 200 of its cutting-edge Pulstar Pultrusion machines in 25 countries. Always in search of new and better applications for FRP, Strongwell has also developed highly effective armor panels. The pultrusion process required to stop a large caliber, high velocity bullet will come as quite a surprise.
We've got core products that we have sold for years, ladder rail, for example, that we've sold for years and years. We've got other products that are developed for specific applications. The ballistic panel is a good example of one of those, where the government and the Army had a need for overhead protection that was lightweight, that could be moved around, that could be taken down easily, put back up, and that product was developed for that application.
If we make a good panel, a bullet would go right through it. So we had to come up with a way to, what I call it, make a bad panel. It needs to delaminate. And normally you do not want that to happen. But as a bullet strikes a panel, the layers of reinforcement start delaminating, and that absorbs energy and stops the bullet.
What we're looking at here is literally a half-inch thick piece of material. And that half-inch thick piece of material, if you notice along the edge here, there's lots of layers. And this is ballistic material. Unlike a lot of our more common stuff, it's designed to come apart. It's designed to delaminate. Because if you look at the front of this, you'll see there are 3 places where it has been shot. In this case, with a .44 Magnum bullet, 3 different times. If you look at the back side of that, it's smooth. There's nothing there except a little bit of bulge because these bullets have been captured. And so normally what you don't want to happen with one of our products is for it to delaminate, for it to come apart, but the designation here is so the energy gets absorbed. And so when you get into this, when you look at this, if you start to tear it apart, what you will find is the chemistry and the engineering that went into this is purposed to make sure that the bullet gets captured and stops that thing.
Here, a half-inch thick piece of HS armor is tested using Underwriters Laboratory 752 Level 3 specifications, which call for a .44 Magnum pistol at 15 feet with a 240 grain lead bullet with a minimum velocity of 1,350 feet per second. When the Bristol Police Department came to Strongwell with a problem being shot at, Strongwell offered its HS armor panels as a solution.
In 2006, we were looking for a replacement vehicle because we'd been using a 1980s panel van that we got from military surplus to haul our SWAT team, to different calls. It had reached its end of life. We purchased this. We then started responding to several calls, and we were experiencing an increase in gunfire towards the officers. We had a concern there was no ballistic capability on this vehicle. So we knew that we had a resource right in our own backyard here in our own town, Strongwell company, and we approached them because we knew that they had been making ballistic panels and using them for the military overseas to upgrade some of their vehicles, which were only lightly or not armored. And we were fully expecting to pay full price, but because of the wonderful partnerships that we have in this community, they donated these ballistic panels to the police department.
Strongwell has been in the Pultrusion business since 1956, and over that 60-plus year span has learned what it takes to be a world leader, which is reflected in their mission statement, including a provision to provide secure, desirable employment for its people. Strongwell offers work-study and internship programs within its community for the next generation of engineers, manufacturers, and technicians. This Virginia-based manufacturer is well ahead of its closest competitor on every measurable scale, from innovation to sheer volume of products to giving back to the community and providing good jobs that help drive the economy in Southwest Virginia.
We have multiple locations, but our headquarters are right here in Bristol, Virginia. We have another plant just up the road in Abingdon, Virginia, and so most of our production occurs within 25 miles of Bristol, Virginia.
We're very fortunate in this area that we have a workforce that we can pull from. It's very loyal. If you go through the plant and ask people how long they've been here for several years. And so our tenure for our workforce, not only in our office but on the floor, is very long.
Our people really are a big part of our business. One of the things we love to do is get customers here, not just to see the operations, but to meet the people. Our machine operators and the people down on the floor are the best salespeople we have because they can point out some of the intricacies of the process and why it's important that that piece of glass or that piece of carbon fiber go exactly where it's going. And normally, if we can get a customer into one of our facilities and they get to meet our people and see the processes, it will develop into a relationship. They're great people.
What makes me proud is that I was born in Bristol, Virginia, Kingsmont Hospital, which is now torn down 2 hospitals ago, 1942. And I also had a twin sister. But I left. I never thought I would have the opportunity to come back to Bristol and work, much less own and operate a company. And what makes me most proud is the people that work here that I get to work with every day. I've worked my way up to #1 in seniority, but I like to go out each morning when I get here early in the morning, in the winter before daylight, and go around and talk to our teammates and hear about what they did during the night, what they planned during the day. I like to hear about their spouses, their children. I like to see them get educated and buy cars and homes, and I feel a big part of their life. And what we do here with the teammates does wonderful things for all over the country and the world, and it all comes from right here in Bristol, Virginia. So I could not be prouder than I am of what we can do here with all the people we have working with us.
Well, one of the things that we take pride in is that our products are made in the USA, made right here in Virginia, and so we take a lot of pride in that, and we feel like we can provide a very good product, a better product than what you could buy overseas or in other areas.
I guess there are several different ways to measure it. The way that most people measure it is gross sales, and that information is not always easy to get because a lot of the companies out there are privately held. But we do have the highest amount of gross sales of any pultruder in the world. We pultrude more feet and more pounds than anyone in the world. Corporately, we'll pultrude about 80 million feet in a year. Of that, about 40 of it comes from Virginia operations out of Bristol and Abingdon. Pounds, we'll do, I believe it's 35 million pounds out of our Virginia operations in a year. So, and you can measure it by capacity. We've got 40 plus Pultrusion machines in all of our operations. 30 plus are here in Virginia. None of our competitors anywhere in the world have anywhere near that. Most are below 10. So there are several different ways to measure it, and most everywhere you measure it, we're the largest.
I'm proud that I grew up in this area. I was born, I was raised, I was educated right here. And I never knew that this place was here for years and years. I knew it just by name because we do a lot in the community. But 5 years ago or so, when I started working here, I started realizing how much happens. We literally ship all over the globe from Virginia. We make stuff that nobody else makes right here in Virginia. That's something I'm pretty proud of.
Absolutely. Most of the new product development that Strongwell does is done right here in Virginia, particularly in Bristol. We've got our R&D test facility here. Most of our research and development is done in Bristol for whether it's new raw materials, new products for end markets. We develop those here, and most stay here and get made here or transferred up to our Abingdon facility. But all new product development, corporate-wide, is done here in Virginia.
I'm an American. I'm a proud American. I have traveled all over the world and visited, and there's no place like Southwest Virginia and East Tennessee. I don't plan to move, and I've had many opportunities once I came back here in '72 to move to other places in the world. I want to be here. I'm proud of both the state of Virginia and Tennessee and the United States.
Considering Strongwell pultrudes 100,000 feet of ladder rails per day, how many days would it take to make enough ladder rail to reach the moon? Is it A, 96,000 days, B, 1,200,000 days, C, 46,000 days, or D, 12,672 days? The answer when we return. Made in Virginia is brought to you by At Union Bank and Trust, we salute the dreamers, the thinkers, the doers, the believers, the builders, and the makers. Thanks to your vision, hard work, and innovation, you make Virginia shine. Union Bank and Trust, a partner of Virginia business and a proud supporter of Made in Virginia and Virginia Public Broadcasting. The Moon's distance from Earth varies, but on average it is 240,000 miles away. That's just over 1.2 billion feet. At 100,000 feet of pultruded ladder rail per day, the answer is D, 12,672 days, or 34.7 years of continuous ladder rail pultrusion. With that much ladder rail needed, it's probably better to climb on a rocket, which in the near future might just be made from pultruded fiber reinforced polymers made in Virginia. Next time on Made in Virginia, we're going to bring robots to life with one of the world's leading robotic integrators. Cool and very impressive, almost beyond belief. Next time on Made in Virginia. If you would like to learn more about today's episode or suggest a Virginia manufacturer for the program, you may visit us at madeinvirginia.tv and at wvpt.net.